is your limit the two notes. I know you've missed this flip curriculum, so let's get back to it. On problem number one, the best way to solve it is to factor first the numerator and the denominator. So if I decide to factor both top and bottom, I will end up with this is equal to the limit at x approaches -1 of the top one can be factored to x plus 2 times x plus 1, and the bottom one can be factored to x plus 3 times x plus 1. At this point, I can simplify something. I can take away the x plus 1 from top and bottom. Now, the limit at x approaches -1, all I have to do is plug in -1 into the equation. And if I plug in -1 into the equation, I get -1 plus 2 over, by the way, it is equal to -1 plus 2 over -1 plus 3, which is actually equal to 1 over 2. So this is the limit of the function at x approaches -1. I'll do the same thing for number 3, but before I get to number 3, let's look at number 2. Actually, I want to do number 3 first because it's very similar to number 1. If I factor this, it is equal to the limit as n approaches 3 of 3 minus x over, the bottom would be x plus 3, x minus 3. So it's x plus 3 times x minus 3. Keep in mind, I can simplify this and this, but by simplifying this, I'm creating a negative on top. So this can be written as, this is equal to, once I plug in 3, that'll be -1 over 3, negative over 3 plus 3. But the -1 is because I simplified, and 3 because I'm plugging 3 here. That will give me -1/6. Sometimes you just can't factor, like problem number 2. If you just can't factor it, another way to solve it is using your calculator. So what I would do is, on the y equal, I want the limit as x equal approaches 0. So on the y equal, I'll go ahead and plug in the equation. Remember, alpha y equal will give you this ratio. You don't have to have this ratio. You can use parentheses if needed. Since I'm looking for the limit as x approaches 0, I will also go to my table set, and I will make sure that I will ask to start at 0, but I will make sure that I go by 0.01 to see what's happening right before 0 and right after 0. From there, I'll go to my table. Now, yes, it starts at 0, and of course 0 says an error, but look what happens at 0.01. You get 0.2. Let's look at what happens right before 0. You also get 0.2, 0.199999, which is approximately 0.2. So just based on the table, I can tell that the limit of the function at x approaches 0 from the left and from the right, I get the same value, which is 0. So because it's the same, I can tell that 0.2 is the limit. And again, 0.2 is the limit just because I see that it keeps getting closer and closer to 0.2 from the left and from the right. All right, let's do the next one. The next one says limit as x approaches 0 of 1 minus cosine x over x. What I want you to do is put this on your calculator. Once you put it on your calculator, I will leave my table set the same way as it was because it was starting at 0, and I will just go to my table. Now this time, I want to know the limit at x approaches 0. Check this out. As it approaches 0 from the left, it gets to -0.005. From the right, it gets to 0.005. Yes, these two are not the same, but they both equidistant to the which value? They both equidistant to 0. Now, if you're not convinced by this, you can go back and change your table set. Instead of going by 0.01, let's ask it to go by 0.001. And I will go ahead and start at 0 just to manipulate it around 0. Go back to my table. So let's go right above 0. Once again, it's equidistant because this value and this value are so close to 0. So you get closer and closer to 0. Therefore, I can say this limit is equal to 0. Few properties. Here is it. These are properties of limit. Let b and c be real number. Let n be a positive integer. And let f and g be functions with the following limit. The limit of the function f as x approaches c is equal to L, and the limit of the function g at x approaches c is equal to k. Now, scalar multiples, the limit of x of b f of x, meaning I'm multiplying the whole function by b, all it will give me is b times L. In other words, it gives me the same limit but times the constant or times the scalar b. The sum of difference, if I say sum or difference, if I add or subtract two functions, knowing their limit, well, the limit of the sum or the difference is also the sum or the difference of limits. The product, the limit of a product of two functions as x approach the same value c is also the product of their limit Lk. The limit of the ratio is L over K, is also the ratio. The limit of the power would also be, f was L, so it's L to the power of n. Let's keep going and find now the limit of f of x as x approach c is 9, and the limit of f of g of x as x approach c is -2. I want 4f of x. Well, if it's 4f of x, it's nothing other than 4 times 9, which is equal to 36. The next limit is the limit of f of x plus g of x. Well, it's going to be the limit of f of x, which is 9, plus the limit of g of x, which is -2. And now 9 plus -2 is exactly 7. The limit as x approaches c of f of x to the power of -3/2, where f of x is, the limit of f of x is 9, so this won't be 9 to the power of -3/2. Well, 9 to the power of -3/2 is equal to, is the same thing as 1/9 to the power of 3/2, which is equal to 9 to the power, square root of 9 is 3, 3 to the power of 3 is 27, so it's 1/27. Alright, find each limit algebraically. Let's go ahead and find the limit algebraically. This one says as x approaches 0. First of all, when looking at this, you are tempted to plug in just 0 into the equation. But what will happen if you plug in 0? Look what happens when you plug in 0. You will say it is equal to 1/5 plus 0 minus 1/5 over 0. Well, 1/5 minus 1/5 is 0. 0/0 is not something that you can tell. So once you reach this kind of problem, just stop and think again. So I cannot say this is the answer. What I would do is I will reduce this fraction. So let's go ahead and reduce that fraction. So this is equal to 1/5 plus x minus 1/5, everything divided by x. I will find the common denominator and divide by x. Finding the common denominator will be 5 times 5 plus x. This top one we get 5, this one we get -5. You're going to end up with 5 minus x. Everything is being divided by x, so I can just put the red x here, represent this x over x. So if you simplify, at this point, this is what you will get. Both 5's will go away because they cancel. This x and the red x will go away. So I'm left with -1/5 times 5 plus x. And at this point, I can actually plug in the value 0. And if you plug in 0 into this equation, you will end up with -1/5 times 5 plus 0. And this can be evaluated, and your answer will be -1/25. All right, let's look at example 7. On example 7, just as always, the first thing to do is try to see if it will work just by plugging the value. So I will plug in 0 and get square root of 0 plus 1 minus 1 over 0. Well, I will end up with 0 over 0. So this is not conclusive, so I will not go with this. What I would do instead, I would try to work this out. So every time I have this type of square root, I will try to multiply by its conjugate. So that will be square root of x plus 1 minus 1 over x. And I will multiply the top and bottom by the conjugate, which is the square root of x plus 1 plus 1. Top and bottom, x plus 1 plus 1.
Hello, and sit down. I mean, you have so much light sugar.
Sorry about the distraction, but once you multiply up here, you will end up with x plus 1 minus 1. This is just like a plus b, a minus b. You get a squared minus b squared. So square root of x plus 1 squared is x plus 1. 1 squared is 1. Everything is still over x times square root of x plus 1 plus 1. This extra plus 1 is not inside the radical. Alright, from here what I will do is I will simplify the top, and 1 and 1 will go away, these two. The x will simplify with this x, and I will have now 1 over square root of x plus 1 plus 1 on the outside. At this point, I believe I can plug in 0, because once I plug in 0 into the equation, I can now, by the way, since I'm looking for the limit, I cannot just write this and write the answer. I need to rewrite now that. I'll make it a little different. Limit at x approaches 0 of 1 over square root of x plus 1 plus 1 is actually equal to, now is the time to plug in. That's 1 over the square root of 0 plus 1 and a plus 1 on the outside, giving me 1/2. Okay, let's look at the last one. The last one, we say the limit as y approaches 1. But this is kind of straightforward to me, because all I will do is plug in 1 for y. That will be 2 times x plus 1 minus 5x over 1, and that's all I can do, unless you want to take it a step further to say 2x minus 5x is negative 3x to negative 3x plus 2. Well, this one ends up being in terms of the variable x will stay, because it's just the limit as y approaches 1.